All right, so short break there, but I want to stay on time again. So now we have Chris Currey from Iowa State University. He's going to be speaking to us about photoperiod strategies for spring annuals. So I'm going to unmute Chris here, give him a chance to talk. Chris, can you hear me all right? And can you
I
talk
can
and make
hear
sure
you
your
loud and clear,
microphone's working?
Brian. Yep.
All
Can you
right,
hear me?
I can hear you, Chris.
Awesome.
So Chris, I'm going to hand this over to you.
All right. Thank you very much. Well, first of all, I wanted to thank everyone for coming out today. It's really great to be able to have a chance to speak with all the other folks that are on this webinar. Roberto, that was a great seminar. Thanks for shedding some light on that topic. I'm just going to assume the rest of you are laughing. So today I wanted to cover some photoperiod strategies for spring annuals. And this is, I think, a real opportunity to review how you're managing flowering for your annuals. So why do we want to manage photoperiod during production of our annuals? There are pretty much two main reasons. The first is to induce flowering. By getting our crops into flower, they're going to be more appealing and marketable for sales. Having that flower on the plant gives a consumer an idea of what they're buying, and also some instant gratification for planting into containers or planting into the landscape. Now, alternatively, the flip side we want to control flowering is to inhibit the flowering. And this is when we want to try and get the plants to fill in containers and bulk them up before they start flowering. And a good comparison would be thinking about perhaps a wave petunia grown in a 4-inch pot and a wave petunia planted in a 6-inch pot. You need a different size plant for each of those containers. Or you could also think a 8 or 10-inch basket of fuchsia versus a 12 or 14-inch basket of fuchsia. We're going to need a different size plant for those containers. So both getting our crops into flower or keeping them from flowering can help us improve the quality of our spring annuals. So before we get into photoperiod, I want to talk a little bit about juvenility, because this is a concept that I think it's good to have an understanding of. And juvenility isn't just a poor sense of humor, poor taste in humor with jokes. Juvenility is going to be when a plant cannot flower even when it's grown under inductive conditions, or conditions that would promote flowering. But just like animals, mammals, plants become mature. And this means that the plant can flower in response to inductive conditions or flowering stimuli. And now when we talk about juvenility, for growing spring annuals, it's primarily going to be a concern for seed propagated crops. And a lot of breeders are doing a good job trying to reduce the juvenile period, allowing us to get our crops into flower quicker. Now, it does not apply to vegetatively propagated crops. The reason being is when we grow crops propagated by cuttings, they're going to be mature, so they're already able to flower in response to inductive conditions. So it's something to keep in mind when you're growing plants from seedlings or plants from rooted cuttings. Now, how do we measure juvenility? With woody plants, it would be in years. So we can talk about a 5, 10, 25-year-old tree that starts to flower. But with herbaceous plants, we don't use time so much. One of the reasons is that it's a lot shorter. We're not talking about years for a petunia. We're going to be talking about leaf number. Another reason we use leaf number is if you have variation in growing temperature. You could have a 2-month-old seedling growing in a greenhouse with a 60-degree Fahrenheit air temperature. You could also have a seedling growing for the same period of time in a greenhouse at 70 degrees Fahrenheit. And they're going to have different leaf numbers even though they'd be the same age. So we talk about leaf number when we're discussing juvenility with herbaceous annuals. Now, juvenility and plug size is another thing to think about. Cell size itself does not determine the juvenility or the maturity of a crop. However, a larger plug is going to be finished, transplantable, or saleable when it's at a larger size. And this is going to be when more leaves have unfolded. So just because a seedling is growing in a larger cell doesn't mean it's more mature. But generally speaking, we transplant or sell our seedlings from larger plugs when they have more leaves on them. Okay, so now that we understand a little bit about juvenility, we're going to move into photoperiod, the focus of today's talk. Now, photoperiod refers to the duration of light hours in the day, but it's actually the duration of that darkness that is the signal. but we still talk about it in terms of photoperiod. Now, there are going to be different flowering responses to photoperiod, and that's what we're going to spend some time reviewing today. There are 3 different photoperiodic response groups that spring annuals can be classified into. The first, day-neutral plants. Second, short-day plants. And third, long-day plants, which is one of the most common photoperiodic response group for our spring annuals. There are going to be some other nuances in types of response within a short-day response or within a long-day response, and we'll get to that in a little bit. So first, let's talk about day-neutral plants. Day-neutral plants, flowering will not occur in response to any specific day length. So throughout this presentation, I'm going to use some graphics that I've created in PowerPoint because I feel they help make some of these principles a bit more clear. So here you see we have a short day on top with a small day and a long night. And on the bottom, we've got a long day and a short night. Well, this would be the flowering response for a day-neutral plant. Under a short day or a long day, they're going to flower at the same time. Now, when I say time, I'm generally going to be referring to the number of nodes that are below that flower, or the leaf number below that flower. Generally, I don't use time in response to days because some growers might be growing warmer or cooler. So for this, again, we're talking about the leaf number below the flower because that really indicates if a plant's been induced to flower. So here you can see there's no difference between these. You could grow your plants if it was day neutral under a short day or a long day and expect the same impact of that photoperiod on flower induction, which is none. I think a geranium is generally a good example of a day-neutral plant. Now, short-day plants. Flowering in short-day plants occurs in response to short days and long nights. So here we have an obligate short day response. Under the short day, you can see the plant is in flower. Under long days, you do not see a flower. Now that indicates that obligate short day response, indicating the plant needs to have short days to flower. You could keep on growing it under long days and you're going to grow leaf after leaf after leaf. But we're not growing our spring annuals for leaves, we're growing them for flowers. Now there's another type of short day response, the facultative short day response. So here, the plant on your left, grown under short days, you can see that it's flowering, again, about 4 nodes underneath that flower. Now when we look at the long day, the plant is in flower. But what do you notice that's different about it? Well, it's a little bit taller. Well, why is it taller? It's not necessarily just from internodal stretch. It's going to be that more leaves were formed underneath that flower, indicating that flowering is delayed. Okay, so you see there's about 4 more nodes or 2 leaf pairs underneath that flower, but it still did flower, but it was just later than that grown under the short days. Now, how do you provide short days in the greenhouse? Well, the first answer is move up north to Iowa. We got short days in the winter. Natural short days, they can happen depending on the time of year. You can have natural short days in your greenhouse. And we'll talk a little bit later about what exactly a short day is. But generally speaking, for spring annual production, short days generally occur during the propagation or early finishing portion of production, but before the days start getting longer in spring. Now, if you're using natural short days, be sure to check that you don't have light pollution coming into your greenhouse. And that's going to be some sort of light that might be in a hallway or outside the building that might be shining in and interrupting that dark period. And if you recall what I said before, it's really that dark period that induces the flowering response. The other way that you create short days in your greenhouse is by having blackout cloth. And here we see a couple types of cloth, but if you look at that lower layer of cloth, that's blackout cloth. Blackout cloth or black cloth is used to shorten the day length or truncate it. And it's usually going to be some type of synthetic black fabric with aluminized outside. And it's pulled over the crop in the evening, generally when you're going home, and then it's retracted in the morning when you come to the greenhouse. Now, if you have automated black cloth, you can set different times for that. But pulling this black cloth excludes that afternoon and evening sunlight to make the dark period longer, creating that short day. Now, the next type of flowering response that we have is going to be those long day plants. And this is when flowering occurs in response to long days and short nights. Similar to flower induction for short days, we can have an obligate long day response. You see the plant on your left, grown underneath the long days, is flowering, whereas the plant on the right no flowering under short days. It's an obligate response. Whereas facultative, again, growing under long days facilitates flowering, whereas growing under short days, the plant will flower, but it's going to flower later after more leaves have unfolded. Now, how are you going to provide long days in the greenhouse? And Roberto did a good job of talking about some of the different lighting options for your greenhouse, and some of these are going to apply to providing long days. But really, the first thing that you're going to want to look at is using natural long days. And this can occur during the spring production season, depending on your latitude. It's generally going to be the later part of the production season when the days do start to get longer. In the U.S., the earlier the season, the less natural long days occur. So for those of you down south, or maybe up in the Pacific Northwest with earlier sales date, there may be fewer natural long days in your greenhouse. So to create long days, there are two main strategies. The first is going to be day extension lighting, and this is operating lights before sunrise or after sunset to extend that day length, day extension. Now, the other option for creating long days with lighting is to use night interruption lighting, and this is interrupting that dark period from about 10 p.m. to 2 a.m. What that does is that breaks up that long night into two short nights, creating that inductive long day. So here I've created another graphic just to kind of demonstrate the two lighting strategies. On the top, you see night interruption lighting. We've got that long night, but in the middle, we've got that orange band, and that orange color is meant to represent electrical lighting. And on the bottom, you see two different forms of day extension, where we're adding that light at the end of the day, which is fairly traditional, but you can accomplish it by using that day extension in the beginning of the day and extending the start of the day. So what can you use to induce or to create long days? Well, I think this is probably one of the most classic shots in floriculture. And this is the incandescent lamp with a pie plate reflector. Incandescents are generally one of the most widely used types of lights for photoperiodic lighting. One of the reasons, they're cheap and they're easy to install. Another big benefit of incandescent lights is that they've got a good balance of red and far red light. And although we typically try to avoid too much far red light because it will induce stretching on our crops, some far red light is required for photoperiodic flowering. One of the problems, though, with the incandescent lamp is they're energy inefficient. Lots of radiant energy produced. That's why you've never grabbed them while they're on, right? Next option we have is the compact fluorescent lamp. These are nice and attractive because they've got a lower energy consumption and a longer lifespan than the incandescent bulb. However, there's a problem. There's little or no far red light produced with these bulbs. And this can result in not as effective a strategy for providing long day lighting. A good example is fuchsias or calceolarias. If you're using these compact fluorescents, they won't be induced to flower as quickly because of the lack of far red light. So one strategy that you can use is to alternate compact fluorescents and incandescent bulbs in your greenhouse. And that gives you enough far red light from the incandescent, but you also get some of the energy savings from the compact fluorescents. Finally, this is kind of a new option. It's pretty exciting. Light-emitting diodes, LEDs. Low-intensity LEDs may be used very effectively for photoperiod management. In fact, lots of bulbs are putting out flowering lamps that can simply screw into the same fixtures that your incandescent bulbs were in. And if you choose the correct lamp, one that's made for flowering, it will have a blend of red and far red light to provide those spectra that are needed for flowering. And what's the big benefit of LEDs? Well, it's that long lifespan and it's that low energy consumption when you compare it to other light sources. Finally, high-pressure sodium lamps can also be a useful tool for inducing flowerings. If you're using HPS lamps in your greenhouse already for supplemental lighting, and I'm sure after hearing Roberto talk, you're all going to go out and get HPS lamps, right? Okay, good. So these can be used for photoperiodic lighting if you're using day extension lighting, and a lot of growers will use their HPS lamps in the afternoon and evening because of reduced energy cost. Another option, and it's the one that you see on the screen, is it's an HPS lamp with an oscillating reflector behind it, and this is called the beam flicker. And what this does is you use one lamp, but that oscillating reflector goes through the greenhouse and it can cover a wide area. So it means you use fewer lamps than if you were using perhaps just regular HPS lamps. But don't use these beam flickers for supplemental lighting because you don't get as much light as you would out of a regular stationary HPS lamp installed at a proper density. Okay, so this is a great question. what is a long day or what is a short day? And the classic answer is it depends. And it's not just a cop-out, it really does depend. So one concept to keep in mind is the critical day length or critical photoperiod. And the critical photoperiod is what controls the transition to flowering. And some of the definitions, the photoperiod at or below which induces flowering to short days, or for short day plants, or for long day plants, it's the photoperiod at or above which induces flowering for long day plants. So here again, I've got some graphics to illustrate this principle. We've got a range in day lengths from 10 hours long until 16 hours long. And you can see on the right-hand side, we transition from vegetative growth to flowering as the day goes from 10 to 12 hours. So here, we would say that the critical day length for this long day plant is 12 hours. Similar example, for the short day plant, we've got days lengths ranging from 8 hours to 14 hours. And you can see that flowering transitions to vegetative growth as the day length goes above 12 hours. So for this plant, it would also be a 12-hour critical day length. Here's an example from some research that I did for my master's degree. And this just is meant to illustrate the variation in critical day length among species. And these are actually 3 different species of Kalanchoe, so they're highly related plants. They're in the same genus. But you can see when we look at the transition from flowering to vegetative growth, that it's not the same for all the species. For Kalanchoe glaucescens, on that top row, we have a critical photoperiod of about 13 hours, whereas for the other 2 species, 12 hours is going to be that critical photoperiod. Now, the next question is, how long do I need to keep my plants under these different photoperiods to induce them into the flowering? Well, again, that's going to depend. The critical cycle number is the length of time that plants must be exposed to different inductive photoperiods to induce flowering. And it's generally going to be that minimum number that plants need to be under that short day, if they're a short day plant, or under that long day, if they're a long day plant, to induce flowering, even under non-inductive conditions, okay? So let's fast forward here. We've got some cosmos, and these, again, this is from my time at the University of Minnesota. Now we took these cosmos, which is a short day plant, and we grew them under long day conditions, non-inductive conditions. Then what we did is we took the plant and transferred them over into short days for varying lengths of time, and then transferred them back into long days, that non-inductive long day. And so you can see on the left-hand side, we have the plants that received 0 inductive short days, and they're still vegetative. Now, as we move to the right, you see the plants that received 6 inductive short days or 12 inductive short days are still not into flower, whereas those that got 18 short days or more were induced into flower. So you can say that Cosmos has a requirement for about 2.5 weeks of short days to get them into flower. And this again is going to be a similar concept for long day plants. You're going to need to expose them for a certain number of long days. Now, one strategy that you can use is for the long day plants, once they're induced to flower, switch them back over into non-inductive short days, and it'll help control some of that excessive stem elongation that you might get, or that bolting. And that's called using a limited inductive photoperiod, minimizing the amount of long days after flowering is completely induced. So there, again, just demonstrating 18 cycles is the critical cycle number for Cosmos. So how do we bring this all together? Well, we just have to think about what our goals are for spring annual production. So managing the photoperiod during annual production can really improve your crop quality. And again, it goes back to that first slide, why we want to manage flowering for our crops. First, we really want to try and get our plants in flower for sales. It's a proven strategy to increase the sale of plants. Secondly, it's a way to manage the vegetative growth for plants that we may need to bulk up. I think you've all seen some hanging baskets that you've planted with maybe petunia plugs that start flowering prematurely. Well, one, that's going to take energy away from the vegetative growth. Two, you don't want those plants flowering the whole time they're being grown in your greenhouse, because those old flowers will slough off and they're going to be a source for disease during production. So keep this in mind. Early in the season, the days are going to be naturally shorter. So if you're trying to get a long day response, think about some of those strategies we use to get a long day response. Some of that day extension lighting, some of that night interruption lighting. Alternatively, later in the season, you're generally going to be getting closer, or you will have naturally long days. So if you're trying to grow some short day plants, think about how you're going to use black cloth to try and get some flowers on those crops. And this is one of those things where you doing some planning ahead of time, you can successfully manage flowering. And I think I'd like to agree with one point Roberto make about managing light during the young plant phase. During the plug phase or the liner production phase, that's a good time to manage flowering. So it's good because it's a small area, so we can black cloth 1 or 2 benches pretty easily. So if you're growing marigolds for a pack later in the season, you might be able to grow those plugs on a specific bench and pull some black cloth over them and then transplant them to the packs, and they'll already be induced into the flowering stage. Similarly, for those wave petunias that you have a hard time getting into flower, use some lighting during propagation to get them induced so they might be flowering at the right time once you transplant them. So with that, I'm going to go ahead and take a breath, and I'd like to open it up for any questions that you all might have about photoperiod management and flowering.
All right, thank you, Chris. So like Chris said, if anybody has any questions, we have some time to take some questions. Go ahead and ask those questions now. We've got the time. Also, if you happen to have some questions about supplemental light, you can ask that question now as well. It looks, and we can probably try and field those questions at the same time. Any other questions? I haven't gotten any questions typed in. Oh, here we got one.
Okay.
All right. So, are there any pros or cons between day extension or night interruption lighting?
Okay. You know, I can't answer that completely clear across all plants. I think sometimes using day extension lighting, some people have said that they don't seem to get as much stem extension using day extension lighting versus night interruption lighting. But again, I don't have data to completely back that up. It's just anecdotal from what I've heard from some growers. But as far as just inducing flowering or successfully inducing flower or unsuccessfully inducing flower, not so much.
All right. A couple of people asked if there's a list of crops with day length requirements, and Chris, I'll let you answer this. But I think if you all scroll up in the chat window, back a ways in the first session, Roberto put in a URL for a link of an extension publication. And I haven't clicked on that, but I have a feeling that he has that is the URL for a list like that. Chris, do you have any comments on that?
Yeah, Roberto and myself and Neil Matson from Cornell actually put together a Purdue extension bulletin that's called, I think, Flower Induction of Annuals. And you can get that from Roberto's website. And that's got an extensive list of the photoperiod classifications of these annuals: short day plants, long day plants, facultative short day, obligate long day, so on and so forth. One of the questions that someone asked was, is there a list of the day length requirements? And this is kind of a sticky situation, because if you think about your greenhouse full of annuals, it's going to be hard to provide a 14-hour day for this plant and a 15-hour day for this plant. So generally speaking, when you're inducing your crops to flower, typically we use day extension to get a 16-hour photo period, or just use night interruption. And then you don't need to worry as much about that critical photo period, because you're interrupting that long dark period and making 2 small dark periods. So if you're trying to get a one-size-fits-all operation, a 16-hour day with day extension or 4 hours of night interruption is usually a pretty good bet.
All right, I did check that URL, and I was correct that it is the Flower Induction of Annuals PDF that Chris, Roberto, and Neil Matson put together. I reposted that in the last chat window, so you can click on that, and that's a really nice publication that they put together. Got a question: are there any wireless 24-hour light meters available, Chris?
I don't know that there would be light meters that are wireless from the sensor to the greenhouse computer. I think those are all hardwired from what I understand, but you would have wireless capabilities from the computer to whatever device you're interested in checking. You know, those types of wireless connections are possible with greenhouse computers. But as far as the light sensor being just wireless on its own, that can send data to you, no. Spectrum has a little light sensor, but it won't send the data off.
All right. Any other questions that people have? We've got a couple more minutes to field those questions. All right. Well, thank you, Chris. Thanks for your time.
Thanks for having me, Brian. Appreciate it.
No problem. I'd like to, again, just thank everybody for joining. We're going to take about a 30-minute lunch break now, and then we'll come back here at 12:55. Before we go to lunch break, again, just some more housekeeping announcements. First and foremost, I want to thank Proven Winners for their sponsorship of this webinar. It's been a great thing to be hosting. It's been great response from everybody on this. And these sponsorships make these webinars possible to offer to you all free through the e-GRO website. If there's something that you've missed or something that you can't get to, or you know somebody who couldn't get registered for this webinar because we did fill this webinar up pretty fast, we are recording these sessions. We'll have them broken up by topic and posted on our website, e-GRO.org, in the next 10 to 14 days. We'll also have the PDFs. I did just see a couple of questions come through. Chris, if you're still there.
I am still here.
Do you have a recommendation for a good portable light meter?
You know, there are a number of good portable light meters out there. So let me say that the use of trade names does not imply endorsement of or criticism of those not mentioned. That being said, one that I'm pretty familiar and comfortable with is the portable light meters by Apogee. APOGEE. So that's right. I think that's a pretty good light meter.
Okay, and then another question about how does boom lighting compare with HID lighting?
Well, I would ask what type of lighting is on the boom, because I've seen LED lights on booms. I've also seen high-pressure sodium lamps on booms. So without knowing a little bit more about that, boom lighting can be very effective. In a way, it's similar to that oscillating HPS lamp, which is really a type of, it's called cyclical lighting, where you don't have to have your plants lit for that entire 4 hours of night interruption. It's just you keep on flashing them with light a certain percentage of the time, kind of to remind them that it's not night yet. And boom lighting is similar to that, where you're passing a light over there. So without knowing more about the light source on the boom, it can be just as effective. As long as you get that right, get the light onto the plants, 2 micromoles.
Okay. Okay, if you do have any other questions for Chris or any of our other speakers, please feel free to email them. Their emails are listed on the handouts if you download the handouts. If you haven't downloaded the handouts for any of the sessions, especially the sessions coming up, you can download that from the Materials tab on the GoToTraining control panel. So go ahead and do that so you have those to reference as we're going through the rest of the afternoon. Again, would like to thank you for participating. We're going to take about a 25 or 30-minute lunch break. I'll come back in at 12:55 to welcome all of you back. And we'll start up with our afternoon sessions, starting with Don't Get Tripped Up by Thrips, Effective Thrips Management. Ray Cloyd is going to join us and talk to us about all of our favorite insect pest thrips. So please stick around and join us at 12:55 for that.